Hi, this is Roman, and today we're going to be going over Unit 8 on conditional probability, Day 15, with the focus question of how can we use notation to find conditional probability of events A and B. So I'm just going to walk you guys through a few examples, just go over the premise of the idea here. So today we're going to be looking at the probability of A given B. So I have a Venn diagram here to illustrate what it might look like as a picture. So let's say that we have the probability of B and the probability of A. And what we're looking for here is the probability of A given that B has occurred. So the first thing we want to do is say that B has occurred here, right? And then we want to know the probability of A if B occurred. Well, A is right here that I've highlighted in red. So it's almost like saying that that is the probability of the red over the probability of the blue here. And as we look in the formula that we have, we're told that the probability of A given B is going to be the probability of A, make that capital, the probability of A and B over the probability of B. Right, and as we go into this, we should be following the rules that we've learned about probability. And we could even simplify this to say that the probability of B, of A and B is the same thing as the probability of A times the probability of B divided by the probability of B. And that's another way to simplify that. One thing that I do want to point out here is that as we're given this probability, we're dividing by the probability of B. So we're dividing all the possibilities of B that occur. And this is a recurring theme because in all the other probability questions that we've done to this point, we've been dividing by the total possible of outcomes, or the total possible outcomes in a scenario. So let's take a look at a question here. So in this question, we have a deck of cards, right? And we're asked to find the probability of A and B as it's given that it's equal to the probability of A given B times the probability of B. So we're told to explain or show our reasoning as it relates to whether the question or whether the equation is accurate. So let's take a look. For question A here, we're asked, or we are told that event A is the card being black, and event B is the card is a king. So let's find our probabilities here. So we know that the probability of A given B is going to equal the probability of A and B over the probability of B. So let's start filling in some of these things that we might know. The probability of a card being black, or our first event, well, we're going to say that's 1/2 of the time the deck, half of the deck is black. The second event, or event B, so we'll say the probability of B, that the card is a king, well, that happens 4 out of 52 times, right? 4 cards, as I highlight them here, 4 cards out of the 52 are black. So now if I use my formula, A given B, this is going to equal the probability of A, 1/2, times the probability of B, 4 over 52, divided by the probability of B, or 4 over 52. And we can divide out and we'll get that the probability of A given B is 1/2. So I'm going to create a little bit of more space just to finish this question up. Let's create a box here, and we will be addressing B in a second. So now let's answer the question that was being asked here. Let's see. What would be the probability of A and B, right? So we want to know the probability of A and B. So the probability of A and B, well, that would equal the probability of A given B times the probability of B. And now we have all this information here, right? So the probability of A given B, we said that was 1/2. The probability of B is 4/52. And we'll see that that's equal to the probability of A and B, because we know that the probability of A and B is just equal to the probability of A times the probability of B. So we see that this is a valid equation, and it is accurate in this case. One more thing, if we might be asked to simplify here, right? Always have your Desmo Scientific Calculator handy, right? So if we were asked to do 1/2 times 4/52, we could definitely show that, and then we could use our fraction bar here to see what an equivalent fraction would be to get 1/26 here if we're doing 1/2 times 4/52. So that's A, and I'm going to just copy this and take a look at B at this point. So for B, we are asked if event A is the card as a face card. So let's take a look at that. If we take a look at the face cards here, right over there, well, we could tell that a face card, there are 12 of them. So we could say that if that is event A, the probability of event A is going to be 12/52. And then for event B, if that's a spade, well, the probability of B is going to be 13/52. So now if we solve for the probability of A given B using our formula, we would do the probability of A times the probability of B, and then we divide out the probability of B here. Right, so now if we take a look at this original, the probability of A and B would be 12/52 times 13/52. And that should equal the probability of A given B, which is 12/52, times the probability of B, which is 13/52. So this is another valid statement. So this was a sample of a few questions that were completed based on conditional probability, and I hope we found this useful.